Hi guys, welcome to lesson 11 of geography series. Uh, Previous class we have learned about what is atmosphere, constituents of atmosphere, that is gases, water vapor, dust particles, and also what is temperature induced pressures, relations between pressures and temperatures. Okay, we have learned those basic concepts in previous class, and also we have learned about what is conduction, convection, difference between radiation, reflection, all these basic concepts. Okay, yeah. Now jumping into actual climatology, first would be your composition of atmosphere. Okay, right. See, in previous yesterday's class we have learned that atmosphere is very dense in primordial form. After that, the primordial form has been erased by solar winds, and after that, due to volcanic activity and also due to rotation of the Earth, the atmosphere has been developed. And yeah, Earth rotates from west to east, that is anti-clockwise. Okay. It is from west to east, that is anti-clockwise. Okay. Yeah. And the atmosphere that has been developed is divided into many layers. Okay, and the first and foremost layer would be your troposphere. Sorry, the first and foremost layer would be your troposphere. After troposphere we have stratosphere. After stratosphere we have mesosphere. After mesosphere we have ionosphere, and ionosphere is divided into thermosphere and exosphere. Okay, coming to troposphere. Troposphere. Yeah. Uh, Troposphere is the first layer of the atmosphere, and it is mostly in contact with the surface of the Earth. Okay, contact in the sense it is more nearer to the surface of the Earth, and the average distance of troposphere from surface of the Earth is 13 kilometers. Okay, the average distance of troposphere from surface of the Earth is 13 kilometers. Okay, and as we move from equator to poles, the distance of the troposphere decreases. At equator the distance would be somewhat 18 kilometers, and at poles it would be only 8 kilometers. Okay, see, if this is the surface of the Earth, you know wait if this is the surface of the Earth, uh, it is tropical region, 30 degrees, 60 degrees, 90 degrees. Okay, 90 degrees is your polar region. Okay, what happens is at tropical regions we can see sunrise falling vertically, so more heat is generated at tropicals and equator. So what happens at that tropical region, the air particles get heated more rapidly. Once they get heated more rapidly, they develop a tendency to move upwards, to become stable, that is to become cool down, they move upwards. Okay, more is the heat, more rapidly it moves upwards. Okay, and more it pushes the troposphere upwards at equatorial region. So at equatorial region, troposphere will be somewhere at here. Coming to temperate zone, comparatively less temperature at temperate zone. So sorry, so what happens, air rises but not at the extent not much extent compared to tropicals and equatorial region. So at temperate regions the troposphere will be somewhere here, and at polar regions it is frigid region, and the air does not rise much higher. It only rises only very little amount of distance, and troposphere will be somewhere here. So as we move from equator to poles, the distance of the troposphere from surface decreases, and it is about 18 kilometers at equatorial region and 8 kilometers at polar region. Yeah. And next, this is the second thing. And in troposphere, we can see dust particles, all the constituents of atmosphere, like dust particles, gases, and your dust particles, gases, and water vapor. Okay, we can see all these constituents present in the troposphere. Okay. Due to this presence of dust particles, gases, and water vapor, we can see formation of clouds in the troposphere itself, and not most of the complete weather activity happens in troposphere. Weather activity. Okay, complete weather activity happens in troposphere due to presence of all the gases, dust particles, and water vapor. Yeah, and another feature of troposphere is as we move from it is troposphere. As we move from lower layers to upper layers, temperature decreases. Okay, in troposphere, as we move from lower layers to upper layers, temperature decreases. Why? The lower layers of troposphere is in contact with the surface of the earth. As the surface of the earth gets heated, the heat is conducted upwards. What is conduction? When two different temperature bodies are in contact with each other, the energy flows from high energetic body to low energetic body. So when two different masses or two different layers of different temperatures are in contact, the layer that's having high temperature conducts its heat to the layer that's having lower temperature. So the heat is conducted from surface to lower layers of atmosphere. So that's why they are hotter. And as we move upwards, the effect of conduction decreases. So upper layers are colder. Right? Yeah. After troposphere, we have mesosphere. And in between troposphere and mesosphere, we have tropopause. Tropopause, sorry, not mesosphere, stratosphere. We have tropopause in between troposphere and stratosphere. Tropopause is nothing but a transition layer or a zone between the two layers of atmosphere, that is between troposphere and stratosphere. It is a transition layer. What happens in tropopause? In tropopause, the temperature remains constant. That is, as we move from lower levels to upper levels of tropopause, the temperature remains constant. Okay, and second feature of tropopause is the temperature of tropopause is minus 80 degrees centigrade at equatorial region and minus 45 degrees centigrade at what polar region. Why? Same reason. At equator or tropical region, the troposphere is much higher, so that as it is much higher, it will be more cooler, and at polar region it is much lower, and it will be less cooler compared to this equatorial tropopause. That's why it is minus 80 at the tropopause temperature is minus 80 at equatorial region and minus 45 at polar region. Next, stratosphere. What happens in stratosphere? Stratosphere is uh, consists of ozone. Okay, stratosphere consists of ozone. What does ozone do? It prevents harmful UV rays from coming to the earth. It absorbs UV rays and prevents them from coming to the surface of the earth. This is one feature. What is the second feature? In stratosphere, As we move from lower levels to upper levels, temperature increases. Okay, why temperature increases? In stratosphere, as we move from lower layers to upper layers, the density of ozone molecules increase. As ozone molecules absorb this UV radiation, the layers where there are more ozone molecules, it will be hotter. So that's why the upper layers of stratosphere are hotter compared to lower levels. So we can say that as we move from lower levels to upper levels in stratosphere, the temperature increases due to this anomaly. The general thing is, as we move upwards in the altitude, the temperature should reduce, right? But in stratosphere, it is increasing. So that's why it is completely devoid, or it is completely free from cloud formation. No cloud. Sorry. No cloud formation. As there is no cloud formation, it facilitates the traveling of aeroplanes. It is much easier for aeroplanes to travel in stratosphere. And another thing is, this stratosphere extends from up to 50 kilometers. Here we have stratopause. Okay. Above stratosphere we have mesosphere. Okay, which extends from up to like 80 kilometers. Again, in mesosphere, what is the peculiar feature? In mesosphere, as we move upwards, temperature reduces. Why? The lower levels of mesosphere are in contact with the upper levels of stratosphere. So the heat conducts from upper levels of stratosphere to lower levels of mesosphere. Okay, that's why lower levels of mesosphere are hotter, and as we move from lower levels to upper levels in mesosphere, temperature reduces. So clouds will be formed here. Okay, these are called as noctilucent clouds. And above mesosphere we have thermosphere, and above thermosphere we have exosphere. These two in combinedly called as ionosphere. Okay, and in thermosphere, uh, radio signals can penetrate and pass in thermosphere. So most of the radio communication satellites are placed in thermosphere. Okay, and exosphere. Exosphere extends into outer space. There is no much research for thermosphere and exosphere, and they are also not important because they are not much related to weather activity. Yeah, this is about layers of the atmosphere. Most important is troposphere. Please try to remember the features of troposphere. And yeah, next. Next is insolation. Okay, what is insolation? Uh, the incoming solar radiation is called as insolation. Okay, insolation is nothing but incoming solar radiation. We learned in previous class that the solar radiation travels in short wavelength. Why short wavelength and why long wavelength why long wavelength for terrestrial radiation? I have explained it in the previous class. Please do watch it. Yeah, insolation means incoming solar radiation. Yeah, it comes in short wavelength. Yeah, okay. Next, is this insolation is uniform on the entire earth? No, not uniform on entire earth. Insolation is not uniform on entire earth. Okay, why? Because it depends on the amount of insolation received by each part of the earth depends on many factors. First factor is rotational axis of earth. Okay, what is rotational axis? Yeah, we all know that earth is geoid in shape, that is spherical in shape, and also it is tilted from the orbital plane. See, this, if this is the orbital plane, the earth axis is tilted. Okay, this tilt. Okay, this is the tilt. Actually it should be like this, but this is the actual the axis should be like this if it is perfect, but it is tilt. If orbital plane is like this, earth is tilted like this. Okay, due to this tilt and also the geoid shape, that is geoid shape means bulging at the equator. So the equatorial part in either northern hemisphere or southern hemisphere, the equatorial region, that is the from equator to tropics up to 30 degrees, it is more inclined towards sun. Okay, this equatorial region, see, wait, this equatorial region, it is, okay, this region equatorial from 0 to 30, it is more inclined to sun's rays. Okay, it receives maximum sun's rays. That means the sun's rays falls vertically. Okay, the sunrise fall vertically here. That is, that means they almost make an angle of 90 degrees in this region. Okay, up, okay, from as we move from equator towards poles, the angle made by sun's rays decreases. That means if they fall vertically here, and as we move towards poles, the sunrise fall slantly, not vertically, slantly. Okay, in a oblique way, diagonally. Okay, if this is vertical, the sun's rays fall vertically, almost vertical. It can be like this, somewhat like this. If it is 90 degrees, it is like this. See, okay, 90 degrees, 80, 70, 66. Okay, the more is the angle is reducing, we can see the rays are turning in oblique way, diagonally. It's fall not vertical, it is becoming diagonal. Okay, so as we move from equator to poles, their polar region is tilted away from the sun, equatorial region is tilted towards the sun, right? As the polar region is tilted away from the sun, it receives sun's rays in a oblique way like this. Okay, obliquely. When rays fall obliquely, what happens when rays fall obliquely? The the concentration, that is, um once they fall obliquely, the area covered by the rays reduces. If it falls vertically, it heats this part in very much extensive way compared to this. When they fall slantly, what happens? The heat gets distributed all over the place. If they fall vertically, the heat is concentrated in this place. Okay, so it will be much more hotter in vertical rays. Okay, that's why equatorial to polar regions are much more hotter and they receive more solar radiation compared to polar region. This is one thing. Why it's happening like this? Due to rotational axis. So due to rotational axis, as we move from equator towards poles, the solar radiation received by those regions decreases. Second, angle of inclination of sun's rays. We have discussed it right now. The angle made by the sun's rays on Earth reduces from equator to pole. At equator and tropical region, it makes almost 90 degrees. As we move from equator to pole, what happens? Equator, tropic region, 90 degrees. Okay. What happens if it is a equinox? Equinox means, uh, wait, sorry. If it is equinox, that is the sun's rays fall vertically 90 degrees on equator. The sun's rays will be 90 degrees here. As you move towards higher latitudes, it will be somewhere around, okay, let's take it 70. It would be 66 and half, and at poles it is 23. Okay, the angle of the sun's rays. Okay, so that's why it would be more hotter in equatorial and tropical region, and much more like colder in polar regions. Angle of inclination of sun's rays. So depending on this, we have divided. I mean, we have discussed in first class itself. We divide Earth into three different zones: torrid zone, temperate zone, frigid zone. Okay, if you take Earth, it is equator, right? And Tropic of Cancer, Tropic of Capricorn. That is 23.5 degrees north, 23.5 degrees south. This region is torrid. Right, and 35 degree north, 35 degree south, right? 55, 66 and half. Sorry for this, like I am really bad at drawing figures, so please bear with me. 35, 55, 66 and half, and it is polar region, 90 degrees, right? So from 23 and half to 35, we call it as subtropical. And from 35 to 55, we call it as temperate. Okay, from 55 to 66 and half degrees, we call as subpolar. And beyond 66 and half up to 90 degrees, we call it as polar or frigid. The division is same for northern hemisphere also. Okay, why these temperate regions are divided like this? Because of the angle of inclination of sun's rays is decreasing from equator to pole, so that the temperature decreases from equator to pole, and different climate activities happens in different regions, and we have divided it into torrid, subtropical, temperate, subpolar, polar. Like remember these latitude figures: 0 to 23 and half, it is torrid; 23 and half to 35, it is tropical, sorry, subtropical. 35 to 55, it is temperate. 55 to 60, 66 and half or 65, it is subpolar. 66 and half degrees to 90 degrees, it is polar or frigid zone. Yes, right. And the amount of insolation is also depends upon third factor is length of the day. See, okay. Uh, if this is sun and this is earth, earth rotates in a like west to east in a anti-clockwise direction. It rotates on its axis in anti-clockwise direction, and also it revolves around the sun in elliptical way. Okay, in elliptical way. Due to this elliptical path, at certain point earth will be nearer to sun, and at certain points earth will be farther from the sun. Okay, at certain point earth will be nearer to the sun, and at certain points earth will be farther away from the sun. Okay, uh, on 3rd January, earth is nearest to sun, and it is called as perihelion. And on 4th of July, it is farther away from to sun, and it is called as ephelion. Okay, So from this we can say that in a annually on one day Earth receives maximum sunlight, that is on 3rd January, uh, and on 4th of July Earth receives very little amount of sunlight, that is aphelion. But these two factors are very minimal factors for deciding the weather activity. Okay, it's not much important, but remember that 3rd January is perihelion, that is nearest to sun, Earth will be, and on 4th of July, Earth will be away from the sun, that is aphelion. And next, another factor would be distribution of land and sea. Okay, in northern hemisphere, what happens there will be more land, and in southern hemisphere less land. Okay, whenever there is more land in compared to sea, there will be much more variations in the temperature. Okay, because the land part or the continental part gets heated quickly compared to oceanic part. Why I will explain later. Okay, for time being, you remember that continents gets heated up quickly compared to oceans. So northern hemisphere, there will be much more variations in northern hemisphere compared to southern hemisphere. All right. Yeah. So these are the factors that will, determine the amount of solar radiation we receive or the Earth receives. Yes. Next. Next we'll go to temperature. Why temperature? We have learned about the solar input. Okay, the incoming solar radiation. When the solar radiation comes, what happens? Our earth gets heated up at different rates at different region. It heats up differently. The rate of heating will be higher in equatorial and tropical region, and rate of heating would be lower in polar region. As we move from equator to pole, the rate of heating decreases, and this uh, the rate of heating is measured in temperature. Okay, more is the temperature, lesser is the temperature, then the air present, that is the gases and the atmospheric particles for that matter, water vapor, dust particles and gases together consist of air, we call it. So there will be movement of the air because of this temperature rise or fall of temperature. We can see movement of air, and this movement would be vertical and horizontal, right? Yeah. Now we will look into vertical movement of air. Vertical movement of air. uh, I have explained that as the air particles get heated up, they develop a tendency to rise upwards to become stable, right? Yeah. Let's look into that. And as they move upwards, as the like normal air, let's take normal air. Air can be divided into normal, dry, and moist air. Moist air is dominated by water vapor. Normal air means it fairly contains water vapor and the dry particles. And dry air, it completely devoid of the water vapor, right? In For normal air, for vertical movement, as the air moves upwards, when normal air gets heated, normal air gets heated, rises up, and like for every rises up, and for every 1 kilometer of rising up, it would reduce by minus 6.5 degrees centigrade. It is called as normal lapse rate. That means at ground, the temperature of air is let's say 30 degrees. As it move 1 kilometer higher, its temperature would be 23.5 degrees centigrade. Okay, it is called as normal lapse rate, and this normal lapse rate, it is for normal air. For moist air, normal lapse rate would be minus 4 degrees centigrade, and for dry air, it is minus 10 degrees centigrade. Why this difference? You know, moist air. Moist air consists of mostly water vapor. Okay, what happens when moist air gets heated up? These water vapor molecules they absorb the um, you know absorb the heat energy. They get heated up, but at a very slow rate. They heats up very slow rate. If the sun's rays hits dry air and moist air, which air gets heated up more quickly? Dry air gets heated up more quickly because it does not absorb it. Its temperature rises. That's all. It does not absorb and store that heat. It just for the time being, as like as much as the the sun's rays are in contact with the dry air, its temperature rises continuously. Whenever the those sun's rays get erased away, its temperature drops rapidly for dry air. It heats up quickly and loses quickly. But moist air, what happens? It absorbs heat energy, and it gets heated up, but at very slow rate compared to dry air. It would be much hotter than normal air, but it gets heated up at very slow rate compared to dry air. Okay, if normal air temperature is 30 degrees, dry air would be 32 degrees, and moisture would be 31 degrees. Okay, because moist air absorbs heat, and it takes time to get heated up, but dry air gets heated up quickly. And moreover, moist air loses heat in a very slow manner, but dry air loses heat very rapidly. As the temperature drops, the dry air loses heat quickly because it does not absorb it, it just gets heated up. And moisture, what happens? If sorry if this is moist air, and there are water vapor molecules surrounding it, moist air, what happens when the temperature drops? Oh shit. Uh, this is the air particle, and water vapor is surrounding it. Okay, whenever the temperature drops, one water vapor molecule releases heat, and it is absorbed by another molecule, and this cycle continues. So what the rate of losing would be much lower for the moist air compared to dry air. Okay, so and normal lapse rate is, so that's why the normal lapse rate is minus 4 for moisture, and dry air is minus 10. As we move up, dry air loses heat quickly because of the drop in temperature. It loses heat quickly. For moisture, the rate of losing is also slow because of the water vapor molecules surrounding the air. Right? Yeah. And this causes and due to this presence of water vapor and absence of water vapor, the air will be stable and unstable. Okay, let's see what is stability and instability of the air. Yeah. It is moist air. I'm sorry. Okay, it is moist, right? It is normal air and dry air. We'll get into latitude part after this. Okay, moist air, dry air. Dry air temperature is, let's say it is 30 degrees centigrade. Moist air would be 31 and dry air would be 32 at 0 km. 1, 2, 3, 4. These are kilometers. Okay. See, sun's rays fall on the earth. Okay, and dry air gets heated up and rises above. Rises above, it loses minus 6.5 degrees centigrade. So 23.5 degrees centigrade. And for moist air, it would be minus 4, right? It would be 27 degrees centigrade. Okay, it is much moist air is much more hotter than the normal air, so it rises further upwards. 23. And at dry air, it is 32, right? And as it moves upwards, it drops for 10 degrees centigrade and it would be 22, right? Compared to this is more normal air, 23.5. So it did not attain the stability. Okay, what is stability? If the air in certain region, if it is either low, it should be lower than the surrounding, or it should be equal with the surrounding region, then it will attain the stability. If it is much higher than the surrounding region, the air would become unstable. It rises because the surrounding if the surrounding air is much hotter, or like surrounding air is much lower temperature, this air is much higher, what happens? The temperature travels from higher to lower region. So in that moment, the air rises upwards. See here, compared to dry region, normal region is it's higher by 1.5 degrees. It rises further up, it is 17 degrees centigrade. And moisture here, it is much higher than this 17 degrees, so it rises further, and minus 4, it is 19 degrees centigrade. See, the moisture is rising upwards in a much rapid way. It rises for a like up to extent where it attains this stability, moist air. If this normally rises further up, what is the temperature? It would be 10 degrees centigrade. So this moisture is still higher than the normal air, and it rises further up, 15 degrees centigrade. It is 4 degrees centigrade. Okay, still did not attain the stability because it is much higher than the normal air, and it rises again further up, 11 degrees centigrade. And this happens until this rise happens until the moisture attains stability. That is, uh, the moisture should be much lesser than the surrounding air. It rises up to extent where it is much lesser than the surrounding air. It rises upwards, and same is the case with the normal air. It rose upward as it attained the stability compared to surrounding regions. Okay, see, and dry air, it rose for 1 kilometer high, and it got reduced compared to the surrounding temperature, and it does not rise further. Okay, that means it attained the stability. Dry air attained stability. It does not rise up further. Attained stability. Normal air attains stability much lesser than dry air, and moist air attains stability much more lesser than the normal air. So this is what air stability and instability. More is the water vapor content, more is the instability for the air. Okay, that means like more is the water vapor content, more uh, more is the temperature it would generate, like not generate, more is the heat it would absorb, and more is the rise in the temperature. So more is the rise in the temperature, more will be the vertical movement, much higher it travels. Okay, this is one thing. So we have come to a conclusion that moist air is unstable and dry air is stable comparatively, and moisture rises much more up compared to dry air. This is one aspect. Second aspect is where we can see moisture in equatorial and tropical region, because it is much more covered with the oceans. Whenever the air is in motion, it travels from sea to land, and while traveling from sea to land, it brings some moisture with it. Okay, as it brings some moisture with it, it becomes moisture and rises upwards. As it rises upwards, these moisture gets condensed at the upper layers of the atmosphere due to drop in the temperature, and these clouds, these water vapors condense into clouds and results in the rainfall. That's why there is more rainfall in equatorial and tropical region. Okay, and more cloud formation is present in equatorial region only, because there is more ocean, more is the more it heats, more it gets heated, because of the vertical sun rays, it gets heated very like very much higher, and the water vapor gets evaporated into atmosphere. It rises upwards and condense into clouds. Okay, and normally that is subtropical. As we move from like equatorial to what we say tropical region, what happens, the moisture content in the air decreases, and it attains stability much more faster, and the rainfall also decreases in this region, in this normal region, that is tropical and subtropical region. Okay, and dry air would be in polar region, and again there is temperate region, right? This temperate region, there will be more rainfall because of air masses. We'll come into it in next chapter. Okay, but the moisture content in the air is reduced from equator to poles. Coming to dry regions. Okay, that means these are regions away from the ocean. Okay, regions away from the ocean, stability is very much pronounced here. More is the stability, less is the rise of the air. Less is the rise of the air, uh, less is the cloud formation, and less is the rainfall. Okay, so that's why if you observe, the western parts of the continents contains mostly desert regions. Avatar, Sahara, Namib Desert, and all, they are western part of the continents, and there is a very less rainfall due to dry air in those regions. Dry air causes stability, and this stability does not result in the formation of the clouds. So less rainfall. More is the moisture content, more is the air instability. Okay, this is about the like vertical movement of the air. Next, horizontal movement. In horizontal movement, there are two aspects: sea breeze, land breeze. Okay, sea breeze and land breeze. In summer or daytime, continental part, oceanic part, sun rays are falling on both of them. What happens in summer? That is, in summer, in the sense, the like more is the insolation. In summer, it would be more insolation. Okay, uh, why it is more insolation and all, we will discuss when coming to seasonal variations in temperature. Okay, first listen to this. But we have completed vertical movement, and now we have shifted to horizontal movement of air. Why air is set in this vertical and horizontal movements? Due to rise in its temperature. Okay, yeah. What happens during a summer or a daytime? Land get heats quickly. Land gets heated quickly compared to oceans or sea. Why? See, as soon as the sun's rays fall on the oceanic part, they, in order to heat up the entire ocean or the much upper part of the ocean, the sun's rays does not penetrate more than 72 meters below the ocean, or 77, I think so. Just take it out. Okay. They does not penetrate not more than 72 or 77 meters, and as they have to deep penetrate much more deeper, it would take more time for oceanic part to get heated compared to land. So we can say that land gets heated quickly. Okay, that is one thing. It gets heated quickly, and moreover, above the oceans we can see formation of clouds. Because of the rise of water vapor and condensation, we see formation of the clouds on the like above the oceans. So it would be harder for the sun's rays to reach the oceanic part, because the clouds reflect the sun's rays. Okay, so because of these two reasons, the continental part of the land part gets heated up quickly in daytime or in summer times, and oceanic part gets heated up very slowly. So what happens? Sorry. Land part has high temperature, and oceanic part has, sorry, oceanic part has low temperature, and land part will have high temperature. What did we discuss in the previous class? Whenever there is high temperature, there would be a low pressure. Because of the rise of the air upwards, the particles get scattered away and pressure would be low, and high pressure here. And winds, air in motion is called as wind. That's all. Winds travel from high pressure to low pressure regions. It is called as onshore winds or sea breeze. It is horizontal movement. This is one thing. Second is land breeze. What is land breeze? This is continental part, this is oceanic part. Okay. During winters or night, what happens? Land loses heat quickly. Okay. Land loses heat quickly compared to oceans. Why? There are cloud formations above the oceans, and during terrestrial radiation, the rays gets reflected back into ocean. Okay, so oceans would be much hotter in winter time or night time, high temperature, and land loses the heat quickly compared to oceans because of this reason. Due to more clouds on the above the ocean, the rays are reflected back. That is, the terrestrial radiation is reflected back into ocean, and it's harder for the ocean to lose heat quickly compared to land. So low temperatures on land, high temperatures on the ocean. So low pressure on the oceans, high pressure at land. Air would move from high pressure to low pressure regions. That is from land to sea. That is called as land breeze. Okay. This sea breeze and land breeze is due to horizontal movement of the air. Okay. Compared to vertical movement, this horizontal movement is much more like important in weather activity for a local, for a specific regions, because due to this variation of temperatures in land and sea, there would be sea breeze and land breeze, and many local winds are generated here. Because of this local winds, the regional weather activity is much more influenced because of this local winds. Okay, this is about vertical and horizontal movement of this inversion of temperature. What is inversion of temperature? Generally, what is the notion? As we move from lower region to higher regions, that is altitude, lower altitude to higher altitudes, what happens? The temperature decreases. Okay, as we move from lower altitude to higher altitudes, the temperature decreases. Why the temperature decreases from higher altitudes to lower altitudes to higher altitudes? At sea level, what happens? Due to terrestrial radiation, that is, Earth receives heat and it also radiates back into atmosphere. Okay, when Earth is radiating back, we call it as terrestrial radiation. When terrestrial radiation happens, what happens? The atmosphere is at sea level, they get heated up quickly compared to higher altitude regions. So higher altitude regions are like they are much colder compared to regions at sea level. That is why as we move from sea level to higher altitudes, temperature reduces because of the absorption of terrestrial radiation by the atmosphere at the sea level. Okay, this is normal rate of temperature. But what happens? Inversion of temperature means as we move from low level to high level, temperature increases. The lower levels would have low temperatures, right? This inversion is of three types. Okay, first one would be valley inversion. This is mountain and this is valley. Okay, yeah. During night times or or in winters, the upper regions are colder and lower regions are hotter. Okay, due to this temperature difference or not temperature difference, they are much colder. Cold air is dense in nature, hotter air is light in nature. Because of this, this cold air descends down and settles in the valley, and hotter air rises up because it is less dense. So at valleys we can see during winters or during long nights, we can see the valleys are colder compared to upper regions. Why? The colder region from the mountain descends down and settles in that valley, and the hotter air in the valley rises up as it is less dense in nature. When they both collide, what happens? The denser one descends down and the lighter one ascends up. So there is a inversion here. It is called as valley inversion. Okay, and this phenomena is called as air drainage. And what happens during air drain? Sometimes in valley side there will be many plantations here. Okay, if we frequently observe in Himalayan region, we can see plantations of apples and what we will say this like it's called kumkum puvu in Telugu. Okay, uh, I cannot get this English name. It's grown in Karwan soils. Kumkum puvu. It's red. color used as a spice. It grows only in that region, Afghanistan, Kashmir region. Okay, that generally these plantations are on the mount. Even coffee plantations also, tea plantations, they are on the the slope region. Whenever there is air drainage, uh, the hot air rises up, right? And this hotter air prevents these plantations from getting frost during winters. No frost during winters because of the air drainage, because of this valley inversion. Okay. Second one is upper air inversion. Okay, what is upper air inversion? It is ground, troposphere, stratosphere. What we said, as we move from lower levels to higher levels, temperature reduces. Okay, but in stratosphere, the lower levels are hotter, even upper levels are also hotter. Okay, and this due to presence of ozone, these hot regions conduct heat downward into upper layers of troposphere. So it becomes hot, and the lower level would be cold. So if we see from the perspective of atmosphere, upper layer of atmosphere, there is a upper air inversion here, because the layer closer to stratosphere is hot and the layer away from the stratosphere is cold. Okay, this is upper air inversion. Third one, ground inversion. For ground inversion to happen, the ideal conditions are long winter nights, cloudless sky, long winter nights, cloudless sky, and stable air. It is ideal condition for ground inversion. What happens in ground inversion? Okay, during night times, the terrestrial radiation get back into atmosphere. The sun's rays are received by the earth, and these are reflected back, radiated back into atmosphere. It is called as terrestrial radiation, and it happens in night time. Okay, whenever it happens in night time, the region nearer to the surface become cold. It happens in, whenever there is winter, the nights will be longer and more will be the radiating back of the earth's terrestrial radiation, and more time it will be colder and more, more favorable for the cold area to form in the region or layer nearer to ground. And this upper layer would be warmer because of the terrestrial radiation, and lower layers would be colder in nature. Okay, this is one thing. Second thing, cloudless sky. If there is cloudless sky, what happens? The air can penetrate upper much easier, because the clouds, if there are clouds, they will reflect back onto the surface. If there are no clouds, there is no reflection. Okay, so cloudless sky is favorable for cold layer to form at the surface of the earth. Second one, stable. Stable air means, if the air rises up, okay, that is, stable air means, in the sense, dry air. The air is much, no moisture in the air. As there is no moisture in the air, what happens? It does not rise above much quickly. It does not absorb this dry air does not absorb the radiation of the earth. Moisture, what it does, it absorbs the radiation of the earth because of presence of water vapor molecules, but dry air does not absorb terrestrial radiation, and it it would be easier for terrestrial radiation to escape away from the ground, and cold region of a layer of cold develops at the ground, and the upper layers would be warmer because of the terrestrial radiation. Okay, so that's why during long winter nights, we will observe in the early morning there is formation, and this cold air is denser, right? And due to and within this cold air, these dust particles are suspended in the form of clouds in the cold layer on the ground, suspended in the form of clouds on the ground, and it is called as fog or mist. That's why we can observe presence of fog or mist in the when there is long winter nights and favorable conditions, and it is called as ground inversion. At ground there will be inversion. And what are the conditions that are necessary for this to happen? Long winter nights, cloudless sky, and stable air. Stable air in the sense dry air. Okay. Yeah. That's all for today, guys. In tomorrow's class, we'll this is about temperature. How does heating of the air makes it move, sets it in motion? It would be in vertical and horizontal. What happens when air moves vertical and horizontal? We just learned. And in tomorrow's class, we will learn about heat budget, seasons, why different seasons happen, and if isotherms, and weather systems, about weather systems. Okay, in tomorrow's class. Yeah, if there are any doubts, you please do let me know in the comments. And once again, please pay attention to this class. This class is very much important because we have covered with these vertical and horizontal movements of air. This in turn will decide the temperatures or like weathers in various region or entire climate of certain region. So make sure you understand these logics perfectly. Okay, yeah, thank you.